Hello and welcome to a physics, electricity, and magnetism extra practice video. Today, I will be covering some extra practice around Coulomb's law, using information and questions from the Essential Calculus-Based Physics Study Guide Workbook, Volume 2. So, to review over Coulomb's law, it is described with this equation here. In which the electromagnetic force is equal to the product of Coulomb's constant, the product of the two charges in question, divided by the distance of separation. Here's a chart for more clarification on each of the variables in the equation, and this equation models uh, this equation models situations like this, where you have two charges, Q1, Q2, and you want to find their force or the value of the force of attraction or repulsion between the two. Now, some more important information to remember. K is the Coulomb's constant of proportionality, or its value is 8.99 times 10 to the 9th newtons per meter squared over Coulomb squared. For this example, for the purpose of quick math, we will be rounding it up to 9. The elementary charge of a proton or an electron is regarded as 1.6 times 10 to the negative 19th coulombs. And last but not least, we have like charges repel and opposites attract. By knowing this, we can determine if the electric force will be a force of attraction or force of repulsion by means of the differences between charges 1 and charges 2 and what product they make. For example, if charge 1 is negative and charge 2 is positive, then the resulting electric force will be negative, which results in being a force of attraction. If both are negative, then the electric force will be positive and be a force of repulsion. And same if both charges are positive. Now for the first question. A coin with a monkey's face has a net charge of -8 microcoulombs, while a coin with a monkey's tail has a net charge of -3 microcoulombs. The coins are separated by 2 meters. What is the electric force between the two coins? Is the force attractive or repulsive? To start answering this problem, we should start by writing down the equation we are using. So f of e, or f subscript e, equal to k q1 times q2 over r squared. Since we don't have to manipulate the equation in order to find the electric force, we can go ahead and plug in our information. We know that k in this instance is going to be 9 times 10 to the 9th. So we can do 9 times 10 to the 9th over here. And because these are going to be in, the charges are in microcoulombs, we will have -8 times 10 to the -6 multiplied by -3 times 10 to the -6 over 2 meters. So we don't have to multiply that to a certain power squared. Then from evaluating this, we can get positive 24. And regarding the rules of exponents, these 10s will then become 10 to the -12. divided by 4. And then through evaluating this, we get this to result in our this part of the equation being solved, becoming 6 times 10 to the negative 12. Then from there, we have to multiply this with our value k, being 9 times 10 to the 9th multiplied by 6 times 10 to the negative 12. 9 times 6, it's a very easy 54. While right rules of exponents, this becomes 10 to the negative 3rd. Or this could also be rewritten as 0.054. Now, because this end result is going to be equal to the electric force, our units are going to be in newtons. This could be seen through the evaluation of the exponents here. We know that Coulomb's constant has a value of n times meters squared over Coulomb squared. And then for this part, the other part of the equation, we have Coulomb times Coulomb over meters squared. So these cancel out, leaving us only with newtons. All right, now the question is the force attractive or repulsive? Because we had like charges in the beginning, and because the product resulted in a positive, as seen here, we know that this force is going to be repulsive. For the next question, a small glass rod and a small strand of monkey fur are each electrically neutral initially. When a monkey rubs the glass rod with the monkey fur, a charge of 800 nanocoulombs is transferred between them. The monkey places the strand of fur 20 centimeters from the glass rod. What is the electric force between the fur and the rod? Is this force attractive or repulsive? Go ahead and pause this video and try and solve it for yourself. And afterwards, I will work through it step by step to show you a proper way of addressing this problem. Alright, hopefully pause the video. Alright, hopefully pause the video, and now I'll go over this question. So we're gonna start by writing our equation. Alright. So if you're confused on what to do for the charges, they are both initially electrically neutral, which means both of them initially started with charges of 0. Because there is a transfer of 800 nanocoulombs, this means that the resulting difference between the two is that one has gained 800 nanocoulombs and one has lost 800 nanocoulombs. Right? And then we have our radius, or not radius, our separation distance of 20 centimeters. So we will put 20 times 10 to the negative 2 squared. And now, because I don't want to work with 100, not because these are not in standard scientific notation, I will quickly convert those into correct scientific notation, we will have 8.00 times 10 to the negative 7 times another negative 8.0 times 10 to the negative 7, and we will convert this down here to 2.0 times 10 to the negative first squared. This just makes this a lot easier to work with. All right. Now, if we multiply these two, we end up with negative 64 times 10 to the negative 14th divided by 4 times 10 to the negative second. Then, by evaluating this, we end up with 16 times 10 to the negative 12. Now we have to multiply this by k. All right, now because we haven't plugged in k yet, we know that k is equal to 9 times 10 to the 9th. And now we will multiply this with the 16 times 10 to the negative 12, and we will get 144 times 10 to the negative third, which can be written as 0.144. We know that our answer is a force, so our units are going to be in newtons. And because the product of the two charges is negative, right, when we evaluate this, we end up with our answer being negative 16 times 10 to the negative 12. Now we have to multiply with this with our constant of correlation. Okay, k is equal to 9 times 10 to the 9th. We bring this down here. Multiply this with our negative 16 to the negative 12, my bad. And we will get negative 144 times 10 to the negative third, which can be rewritten as 0.1 or negative 0.114 newtons. Because of the product between the two charges resulting in a negative number, we know that this force is attractive. Thank you for watching. If you have any questions, leave them in the comments of this video, and enjoy your day.